Hey, this is a quick overview of some debugging tips that may help out with this assignment and future assignments. So I'm going to go ahead and run the test bench. And ideally what we'll see is the problems window indicating that all tests have passed. But of course, that's not always the case. So it might be more likely that we run our test bench and we get a list of errors like this. So in the problems window, it'll list the first line where it encountered an error, and it'll give you some feedback on the nature of the error. So it looks like it was in a particular test case in my test file, step 5, it even tells me which line to look at. So in this case, there's a task provided. We can actually look at the details of the test case. We can scroll down to that line and try and figure out specifically what's going on. And it looks like some outputs were not quite what was expected. It looks like I failed 20 of 163 of the different steps and tests that it went through. The other thing that's really useful here, assuming it gets this far, this indicates that it actually was able to run your code. If you have syntactic errors, it won't even be able to generate this. So pay attention to problems, look for syntax errors. The other thing that might be useful is looking at the VCD file that's generated. I'm going to reduce the size of this pane. So the Statemachine test bench itself is the actual code for the full test bench. We can look at that too. There's a task provided, or we could find it in the Task Explorer. So this kind of shows all the things that go into running these test cases. Basically, it's reading in contents of a file, stepping through it, and kind of confirming that your Statemachine does what the file is expecting. One of the things that's important here is it's using a variable called error. And basically, error is being used as a signal, and those signal traces to kind of indicate where errors have occurred. So I'm going to go back to that waveform viewer. I'm going to select Statemachine. If I scroll down in the list here, I'll be able to find that actual error. So here, error is shown. I'm going to go ahead and select that. And that shows me, looks like I also selected cold. So over here in my signal trace view, I can zoom in on this and I can kind of scrub through the timeline here and see where errors are occurring in the timeline. Now, the fact that errors occur at a particular point in time isn't super interesting, but maybe the other signals that are active at that time are. So I'm going to look for where the first error occurs here, and I'm going to go ahead and put this little bar there. Now what I could do is I could drill down in here and I could look at my device under test. That's my actual circuit. I could look at all of the inputs and the outputs and even my state variables and get a better sense of how this is behaving. So this is the exact same sort of debugging that was recommended for the corresponding assignment in JLS, Homework 3B. And this is a common form of debugging things with real-world hardware when you're actually sitting in a lab and oftentimes measuring these sorts of signals with an oscilloscope to actually see how things are changing over time.